So I think that problems like this are important because these three look very similar, but they're actually quite different. So solve for dy dx, or in other words, find y prime. So for part A, the derivative on the left side is going to be 1. Then on the right side, take the derivative of tangent inverse, which is 1 over 1 plus whatever's in the parentheses will get squared. And what's in the parentheses is a y squared. Now do the chain rule. Take the derivative of what's inside the parentheses. So the derivative of y squared will be 2y, and then times y prime from the chain rule. Now solve for y prime. So this is 1 plus y to the fourth. I can multiply both sides by it. It's going to be 1 times y to the fourth on the left side. Then, in order to solve for y prime, the last thing to do is divide both sides by 2y. And that is it. And then for B. So for B, I either made a typo. I made a typo. Sorry about that. This parenthesis is supposed to be right here. So it's supposed to be like this. Tangent inverse of y, and then the whole thing is squared. So again, the derivative on the left side will be 1. And since this squared is applying to the whole thing, take the derivative of the squared function. So that'll go 2 times, and then leave the inside alone, tangent inverse of y, and then subtract 1 from the exponent, so it's now a 1. Now take the derivative of what's inside the parentheses, and the derivative of tangent inverse will be 1 over 1 plus y squared. And finally, take the derivative of this y, and that's going to be y prime. And then similar to this, we need to do algebra. So you could take this 1 plus y squared and multiply both sides. And then we could divide both sides by this 2 tangent inverse of y. And part B is finished. Then what about this one? Well, this square can be written like that, or it can be written like that. They both mean the same thing. And the y to the minus 1, that means 1 over y. So another way to write this problem is like this. Again, the derivative on the left side is 1, and then for this one, the 2 goes down in front, and then it'll be tangent 1 over y, then subtract 1 from the exponent. Now, take the derivative of what's inside the parentheses. The derivative of tangent is secant squared, so this will be secant squared of 1 over y, and then take the derivative of 1 over y. Well, the derivative of, this is another one that I remember, so I don't have to redo it every time. So you could rewrite this as x to the negative 1, and then take the derivative with the power rule and simplify your answer. Or you could just remember the derivative of 1 over x is negative 1 over x squared. So for this one, it will be negative 1 over y squared. And then the chain rule means you need to take the derivative of y. So again, we need to move all this stuff over here to the left side so we could solve for y prime. So this is a y squared on the bottom, so I could multiply by y squared and even take the negative with it. So that'll be negative y squared on the top. And then all of this stuff, you could just divide by 2 in tangent of 1 over y and secant squared 1 over y, and then this would just be y prime.